Alright everyone, welcome back. Today we're going to take a look at how to find multiples of, finding basically the sinus, cosinus, and trigonometric values for multiples of pi over 3. Now let's imagine we have a triangle as such inside the unit circle. Let me just make that a bit neater. Now this triangle is obviously equilateral. Each side of it is 60 degrees. But we divided this triangle into two parts. So that means that the upper value of it is going to also be divided. The angle is going to be 30 degrees. This side is 60 degrees and this side is 90 degrees. Now, we know that the base of this triangle was 1. Since it's divided into two now, each side is going to have a value of half a unit, and this side is 1, obviously, because it's the radius of a unit circle. Now, since we know these two sides, we only have to find the value of this unknown side now. We can do that using the Pythagorean theorem. We know the Pythagorean theorem states that c squared is equal to a squared plus b squared. So we can go ahead and say 1 squared is equal to half to the power of 2 plus k squared. Because those are basically you have to add the addition of those two smaller legs to the power of 2 is equal to the hypotenuse, which is 1 to the power of 2. Let's go ahead and solve that then. We know that 1 squared is obviously 1, and 1 over 2 to the power of 2 is going to give us 1 over 4. So we take 1 over 2 to the other side. We get 1 minus 1 over 4. So k squared is equal to 4. Take a common denominator. We get 3 over 4. Now, in order to get rid of the power of k, we're just going to take a square roots of both sides. That gives us k is equal to radical 3 over 2. Now, since k is to be taken as positive, we are going to accept the positive value of the square root. So this side, k, is essentially equal to radical 3 over 2. Now we can say the coordinates of this point P are then as follows. The x value, which is the one that lies on the x-axis, is obviously 1 over 2. The y value, which is obviously the vertical one right here, is radical 3 over 2. So we found the coordinates of this point. Let's see why that is useful for us. Over here, we are basically showing the same thing, the same triangle, but on a different, essentially on a unit circle. But this time we're going to use basically the radian measures. Let's imagine we shift pi over 6 units forward. So this triangle, obviously, pi over 6 we know is 30 degrees. If we shift 2 pi over 6 degrees forward, that's basically the, that 2 pi over 6 can be simplified into pi over 3. So this time, the triangle that's above the pi over 6 is the 60-degree triangle. So you can say that the coordinates of this point, P, are the same coordinates as the ones that we just found. So it's going to be 1 over 2 for the x and radical 3 over 2 for the y. All right, now as you can see, P over there is just a reflection of the triangle that's down here. So you can assume that the coordinates of this point are going to be the same stuff, the same radical 3 over 2 and 1 over 2, except it's going to be inverted. So instead of the x, you're going to have radical 3 over 2 and 1 over 2. So if you're talking about a 30-degree triangle, that's basically the pi over 6 one, the coordinates are this one. And for the other one, where 2 pi over 6 for pi over t, the coordinates are that one. Why is this important? All right. Let's shift another pi over 6 units forward. So that would be about 3 pi over 6, right? Now 3 pi over 6, if you simplify that, you get pi over 2. So you end up on the 90-degree side, which is right here. Now we already know the coordinates of the pi over 2 part in the unit circle. We know that in a unit circle, this part has a value of 1. This is 1. This is negative 1. And this is also negative 1. And what that means is that obviously over here the x-coordinate is 1. For pi over 2, the x-coordinate is 0, while the y-coordinate is 1. So if they ask you, for example, to find the sinus of pi over 2, you can just go ahead and say, well, the sinus of pi over 2 is just the y-coordinate of pi over 2, which we know over here the y-coordinate is 1. So sinus of pi over 2 is 1. If they ask you to find the cosine of pi over 2, you just have to go ahead and basically look for the x-coordinate of pi over 2, which in this scenario is obviously 0. So let's continue without any further ado. We shifted 3 pi over 6 units. Let's go ahead and shift another pi over 6 units forward. So 4 pi over 6. Which is basically 2 pi over 3 units if you simplify that. So you're going to end up right around here, right? Somewhere like that. Now notice that it's symmetrical with the p, right? So you can call this point p prime. It's going to have the exact same coordinates as p, so it's going to have 1 over 2 and radical 3 over 2, except one thing is going to change. And that one thing is the fact that, as you can see, the x-coordinate now is on the negative side of the x-axis. So 1 over 2 becomes negative. Let's continue and shift another pi over 6 units forward. So 5 pi over 6. You're going to end up right around here. Now 5 pi over 6 has the same, as you can see, it's also symmetrical with this point, with the red point, which I'm going to call x for now. So let's call this point x prime. Now on x prime, you can also assume that it has the same coordinates as x. So you can say this coordinate is radical 3 over 2 and 1 over 2. However, as you can see, the x coordinate of this obviously lies on the negative side of the x-axis, while the y is on the positive side. So this radical 3 over 2 is going to become negative. All right, so why are we doing all of this? What's the importance of all of this? Is this even necessary? Well, as you know, you get questions like find the sinus of pi over 6 from time to time, and you're supposed to do this without the calculator. One of the ways is to obviously go ahead and memorize all the values on the unit circle, or just find the reference angles, which means that you still have to come back to pi over 6 as pi over 3. Another way is to just remember that on the unit circle, for multiples of pi over 3, which is basically pi over 6 as well, you can just do this, what I've done right here. So sinus of pi over 6 over here means this point on x prime. Now sine has to do with the y-coordinate. What is the y-coordinate of pi over 6? 1 over 2. So the answer of sine of pi over 6 is going to be 1 over 2. Let's say they ask you to find the coordinates of for example, cosinus of pi over 6. Is there going to be a difference? Well, we know that cosinus is right there. It's going to be right there. And so we can then assume that the cosinus of that point is just the x-coordinate of pi over 6. And since the x-coordinate of pi over 6 is radical 3 over 2, we can just write radical 3 over 2. Thank you for watching and stay tuned.